Hi everyone, today's lecture is on object-oriented programming principles, part 1. And we'll mainly be talking about inheritance and, briefly about abstraction and polymorphism and so on. But I don't think it's too complicated, and I guess it's fairly easy and logical, especially if you've understood or paid attention to the lecture from the first course, which was Introduction to Object-Oriented Programming. I guess this one should be a lot easier. So, all right. So we'll be talking about the fundamental principles. Then inheritance. We'll spend a bit more time here. After that, abstraction, encapsulation, and encapsulation. I've already talked about this a lot. On a couple of occasions, so not much time spent there. The main things are these two, number 2 and 3. All right, so what are the principles? And okay, so first of all, we have inheritance, which means that you have some structure where you have some class which is parent and some class which is derived. So the derived class has all of the properties, methods, fields, and so on of the parent class, but it can also extend some functionality. We'll do a big example with that, so no need to worry. Okay, abstraction, which means define and execute abstract actions. So this is kind of ambiguous, but this means that if you see two common features between some objects or some classes, you should try to make a parent one which holds these common methods and properties and so on. Encapsulation means hide the internals of a class. Okay, so if so you've used the list quite a lot, and you know that it's relatively easy to use. Behind it, there could be some very complicated algorithms and methods and so on that you do not see at all. Okay, and this is the idea. Take something which could be very hard, with many variables and algorithms and methods and so on. Try to encapsulate it in something that other people can use, and they can use it very, very easily, right? So, list is not that complicated of a structure, but something like a sorted list or sorted hash table or something like that, where when you add an element, it automatically sorts. Well, there is graph theory there. They're automatically sorted and searching, and I don't know what else could be there. I guess recursion as well, and so on. So all of that is hidden by the simple public interface that is given to you. So you can add elements, you can remove them, you can search, and so on. And this is all very, very, very easy. So this is what encapsulation is. Polymorphism is something that we'll talk about next time, but you can access a class through its parent interface or through its parent class. So if you don't need the functionality of your specific class, you can just use one step up in abstraction. But we'll talk about that next time in part 2. All right, so we have inheritance. This is the class diagram that I created from the last course about some animals, and so we have abstract animal, we have bird, we have mammal, we have dogs, cats, and elephants, and so on. So we'll be doing something very, very similar now, but instead of just dragging and dropping, we'll just create it as we have to by code. All right, so let's fire up Visual Studio. And let's begin our project. So I'll need a lot of help from you guys with ideas for properties and methods, what our classes can do and what they cannot do, and so on. But I guess we'll be fine with it today. So okay, so new project, and I want to create a solution, and I'll show you why. Waiting. Okay, I want to create a solution. Blank. And we are going to call this pet shop. Okay. So inside here, I would like to add a new project, and this is going to be a class library for C#. There it is. And I don't know, we'll call this pet shop model for some reason. Okay, and I would actually like to create a running point for my shop. So let's do this here. So test shop. All right. So what's the idea? If you've noticed, the first one is not a console application, but instead I created a class library, which means that this is going to be a library or collection of classes that will model the behavior and the properties of our pets. Okay, so what's the difference between the console application and the pet shop model or the class library? The only difference is that we don't have a main method. So here we have the static void main, and this is where our program will run from. But here we don't have it, right? Here is just the classes, and then I can import them and use them wherever I want. Okay, so let me just do a couple of things here. So let's call this entry point. All right, and okay, so delete all of that. Actually, maybe I want to be using system here. Maybe later on I'll be using system.collections.generic. That is fine. Delete all of that. We don't need it, and make this public. Why am I making it public? So we can access it. But yeah, but I can access it this way as well. Star cop, or yeah, so quality code. Quality code tells us that we should not leave methods or classes without an access modifier. So using the same thing, public static void main as well. All right, so this is our class library, and we'll be doing our pet shop here. But first, let me make a folder here. So new folder, and I'm gonna call it model is fine. I want to create another one for my interfaces, which you do not know yet. So interfaces, and I guess that's that. Okay, let's move this class here, and now I can start typing whatever I want. But right now I cannot access my pet shop model from the class below. Sorry, from the project below. So what I should do is using pet shop model, but I still don't see it, so I have to right click, and here I need to say no, sorry, it's on references. I want to add a reference. Okay, and here projects, there it is, pet shop model. Click OK, and now it should be fine. Yes, and now I can create this class one where so I can say class one, I don't know, test equals new class one. Okay. Also, if I save this, and if I go to the project folder, I should be able to see somewhere around here, maybe not here, release. Where are you? Do I have to build it? Alright, and I want to check it now. Yes, so this is the DLL file that is created, and which holds all of the information about our classes. So this is what the DLL file means. It's just a collection of classes, maybe some functionality and so on. So this is our compiled or built class library right now, and we can add it to different projects if we want to. So these two files, and if you noticed or if you know, they are coded as well, so I cannot just read it straight through. You're attempting to open the file, show apps, maybe notepad. Okay, good luck reading that, right? So it's coded. You cannot normally access it. There are some compilers out there, but I haven't tested any of them out. I don't know what kind of information will you get from it, but it's definitely not going to be the original one that you normally use. Alright, so let's start with our pet shop model. And what is the first thing that we want to do? We want to create an animal. So let's put this into let's rename it into an animal, this one as well. Alright, so here comes your part. What does the animal have? Like, this is a very, generic. Not all animals have legs, so wrong. Wait. Okay, wait. So I learned something yesterday. If instead of prop, I just type prop G, tap, it's gonna automatically create this private set, which is what I want to do. So what did we say? We said wait. Okay, what else? Sorry? Color. Some of them can be transparent, maybe, but still. Okay, public string color, and get and private set. I would like to have a name as well, so public string name, get private set. Anything else? H, get and private set. What else? Okay, speed. Not all of them move. I think some of them don't. Speed is 0. Let's do some methods then. Okay, I wanted to do something else. So public bool is alive. Okay, now please some methods that eat. Okay, let's say public void eat, or make it a string, eat, and we are gonna take food, and I'm gonna create a new class. So control dot, and it says here generate class for food in pet shop model. In new file, and I just press enter, and there is our food. Okay, so public class food, and we are fine. So what does the food have? Let's say I would say calories. Is that, yeah, let's put it as an integer. Something else like simple. Taste. Enumeration. Okay, let's do that. So public taste get private set. Alright, and let's make a new folder here, which is going to be enumerations. So new folder, not inside though. Can I put it outside, please? Is it? It maybe is. Okay, so let's add a new class, and let's call it taste. Alright, delete all of that. This thing has to be yeah, I had to change this to enumerations, and I want to change this to enumerations, and I want to say here public enum taste. And okay, what kind of tastes do you want to have? Sweet, sour, chili, or hot? Let's put it hot. Sorry? Sorry? Awful. Awful is fine. Alright, we don't have salty. Is that the word? Salty, I guess. Alright, let's leave it there. Okay, we don't want to do too much. Alright, so we have the food, and okay, so return. I I ate some food plus food dot taste dot toString. Or do I need to do toString? Maybe not. And a space here. Food dot taste, and we'll see if that works. All right. Okay. What else do we have? Which is yeah, sure. Question. Do the namespaces of the class change automatically? No, they don't. But once I create a folder and inside I create a class, Visual Studio guesses that you wanna put it into a sub namespace. This one, pet shop model dot model, and the food as well. I have to put this. Yeah, the food is dot model. Yeah, we'll fix those as we go. And also I have to be using here the taste. So using pet shop model dot enumerations, and now I'll be able to see the food, right? Because I didn't specifically say go look for it there. Okay, right. So what other methods do we have? Reproduce. All animals can do that? I guess so. Public string in different ways, of course. So public string reproduce. I'll leave that blank for now because we would have to add, two animals. We have to type check and so on, and this is not the idea of the. And I'll put it void as well. Okay, what else do we have? I say die. Public void die. And what do I have to do in this method? It's pretty simple. This dot is alive equals false. All right. I guess that's sort of enough. Okay. Let's so this will be our most basic class. Okay, it will be on top of the hierarchy, and from it we are gonna derive smaller classes. All right, so let's make a new one, and new class. And I'm sure you won't have that many ideas here. So mammal. Okay, delete all of that. So you see that because it's in the folder model, it created the namespace automatically for me. Okay, put a public, and now I would like some, mammal specific stuff from you. Run. Not all mammals run. A dolphin, yeah, the dolphin ruins everything pretty much, because everything that I thought of as common to all mammals, and the dolphin didn't quite have. Give birth. Okay, again with the reproduction thing. Okay, so let's do move. I like move. So public void move, or let's make it a string. I'll say return I moved. Okay. Well, it's just for the demo, all right? You can have more complicated logic. Sorry?
It states I like to move it more.
I like to move it more. Okay, I like to move it. Move it. Is that fine? Okay, fine. All right. How about a property? And this is where things get really hard. Gender. Animals. Do all animals have gender? All mammals do. Good. I didn't quite think of that. Okay, so yeah, I know it's my fault. I'm sorry. I'm sorry. No. I was thinking that there are some animals that are by, how is that called? Have two genders, or they can switch genders or something. Yeah. Anyways, I can't remember the word, but so yeah, let's make a property, and this will be gender, and it's gonna be of type gender as well. and I would like to create one in the enumeration. So add a new class. This is going to be called gender. Public enum gender, and we are going to have male and female. Alright, okay, so right now if I do decide to test my application, you know, there is no specific reason for me to do so, but let's just give it a go. So here I would like to say animal test animal equals new animal, and I don't have any constructors and stuff, but we'll add those later. So I want to be adding the using. Alright, and let's see what we have. So test animal dot, I have, you know, all of the stuff. So I have is alive, I have name, I have eat, reproduce, we have weight, and you know, everything that we just came up with for our animal. Okay, but if I go to mammal, if I create a mammal, test mammal equals new mammal. And let's see what I have here. So test mammal dot, and I don't have that many things, right? So I have the age. It's still animal. Oh yes, sorry. Test mammal dot. Okay, and I only have gender and move. But in fact, what I want to have is everything that I have for the animal, which is also going to be present in the mammal. I want to have it in my mammal as well. So everything that I need to. Oh yeah, I don't have the gender. So gender, and I have to say this, and now we have it. All right. So everything that I need to do is just put a column here and say animal. Okay, and this means that the mammal now inherits everything from the animal. So it does methods, you know, properties, and so on. Everything that is you know, common, I'll have it in the mammal as well. Okay, so let's see it here. All right, now we have the age, the color, we have the gender, we have is alive, we have everything that the animal had. So what are some positive things about you know, inheritance in this case? Is my question. Why would I do this, right? I could have just, you know, copy pasted everything from the animal to mammal, and it was gonna work, and it was gonna show the same thing. So okay, so first of all, repetition of code. We break the dry principle, which is don't repeat yourself. Okay, so this is the first thing. The second thing is that we reuse code. Okay, so if I need to make some changes, I would have to make them in only one specific place. Okay, and if I have, you know, 10 classes which are derived from animal, then I wouldn't have to make that change, you know, in 10 different classes, because I've copy pasted. And of course, you know, it's a lot easier, right? Instead of just writing all of that, I can just say, you know, well, you're an animal, and you should have everything for the animal. Also, structurally, this is a lot more clear for everyone who read it. Okay, so the better abstraction you have, the more, you know, classes which inherit each other. It's going to be a lot more easier, you know, to read your code and to add new functions and so on. All right, so let's go further and extend a little bit more. And now we go to the bunny, of course. So I'm gonna have a bunny. Okay, the bunny is gonna inherit now what? Okay, who says animal and who says mammal? Animal? Mammal? Okay, and we have both of them. Okay, so if I wanted to inherit animals straight away, then I wouldn't be able to get what I got for my mammal, which was gender and move, right? But I want to have that as well. So one option in other languages would be to just inherit both, right? It can be, so it's both a mammal and it's both an animal, and it's also an animal. But in C# you're only allowed to inherit from one parent class, and there are very good reasons for that. So instead of doing something that we actually can't in C#, what I am gonna do is I'm gonna inherit from mammal, and because mammal inherits from animal, I'll also have everything that the animal has. I'll have it in the bunny as well. Right. So what is specific about the bunny? Well, we are gonna do something with the move method. So it's sorry.
Length of years.
Length of years.
Here.
Okay, length of years. Okay, so prop G, and we are gonna say int year length. For yes, something that the mammal didn't. So for what do you say? For count, for length, or for color. Okay, good. But we already have colors, so. Prop G, I like that. So for density, and that should be. I already wrote it down, but yeah, it has to be double. Or if you want to be very very precise, you have to do it as a decimal. Okay. So I want to say for density. For some reason, when you go into the pet shop and you go to the bunny section, and you will see a layer. So this is a bunny, and the first density is 3.58 cubic something over something. It'll be quite funny. Okay, so some method that the bunny can do and the rest cannot. Sorry. Okay, jump. We can do jumps. So I'll say public. Not static. What am I doing? So public string jump, and return another song with jump around. Okay, jump around. This is different from move. Okay. Right, and okay, so let's say that this is sort of enough for now. I don't know. Okay, so now if I go in here and I say bunny, my bunny, of course, equals new bunny. It's unbelievable. Alright, so my bunny, and now I am gonna have everything that the animal has, the mammal has, and the extended things that we put into the bunny. So we have age, color, we have the method die, ear length, which is the specific for the bunny, and so on. Alright, so the idea is that I can make inheritance of however many classes I want. Okay, if depending on your structure, you can have many different types. You can have a very big hierarchy and so on. And every time it's good to make things more abstract. So I didn't start with my bunny because I already know that I'll be doing a pet shop. I started from a level of abstraction above, which was the animal here. Okay, and I started going down until I go to my specific animals that I'll sell in my shop. Alright, okay, so any questions here? Everything is fine? Let's deal with constructors, and since you were so kind to give me that many things, it's gonna be funny to write. So constructor, actually, you know what, I'll just do this. I'll say control dot and I'll click enter, and perfect. Okay, so right here I have to put this everywhere, so this dot, and yeah, this is fine now, but we could have some problems around, so let me just start this again. Okay, okay, so here I want to create a new animal, and what was that, in what kind of order was that? I don't know, it will tell me, I guess. So name, maybe, what was the first one? So we have name, age, so Pesho, he's 1, weight is, I don't know, He's a fat bastard. 15. I'll put a color of cyan.
Make the colors animation.
Boo is alive. Yeah, we can, but you know, this is not something that I'll post on the store. So yeah, it's just for demo purposes. Okay, so is alive. I don't know. Let's say true. Let's not be mean. Although he's, do we not have age? What was the age? Okay, 1. Yeah, right. Okay, so everything now is fine. If I try to build, I should be getting some errors. And yeah, so the problem is that right now, every time when I call the constructor of one of the classes which are below, one of the children, so if I do it this way, I shouldn't be having problems. Or okay, so I still do that. That's fine. So the problem here is that because we have some inheritance, let's go to the mammal, and already here I have this error. So you know, by default, every class has a empty constructor. Okay, sorry, default or empty. It's yeah. Okay, but so I have the animal here, which has this one, which accepts many things, and as soon as I go to my mammal, well, I can no longer have an empty constructor because it has to go to the parent class and look for features there that are not implemented. Okay, so first of all, let's fix this bug, and let's just say let's have an empty constructor, and I want to be setting this is alive to be true, because it will be very bad selling. It will be very bad for the business selling that animal. So it's not gonna be nice. So here I am gonna say this dot is alive equals true. So it will be true by default. And instead of putting it here as well, what do I have to do? Delete this, and okay. So this. And just I am calling the empty one, and it's gonna set this value for me automatically. All right, and now if we try to run it, it's gonna run or not.
We have 5.
I have the same for the bunny, or what happened? What happened here? Oh yeah, I have to put it here. Yeah, I have to remove this. All right, so now project with output line request cannot be started directly. Okay, so I have to set this as a startup project. Maybe from here. Set a startup. Okay, now that should be fine. Okay, so now we run and everything is fine. Okay, right. Where are we? Okay, now I have all of these. So let's go to the mammal first. Now I have all of these things that I don't set, right? So I cannot call the mammal, I think. So right now, if I go back to my animal, so animal test animal 2, new animal. Inside here, I am gonna have the 2 constructors that I just created. But if I make a mammal instead, mammal test mammal equals new mammal, open bracket, and I am just gonna have the empty one. So the constructors are the only thing that you cannot inherit from one class to another, and you have to rewrite them. But fortunately for you, there are some nice ways in which you can do that. So let's do it. Okay, so I am gonna go to the mammal, and where are you? Okay, so inside here I would like to say constructor public mammal, and here we have a lot of things to cover, right? So someone who remembers them? String name, int age, have the insert. So we have int weight, we have string color, and that's it. Okay, so the boolean we already did, but I have to add the gender as well, right? So gender, and right, so inside here I can just do name, because I can access it now, right? It's a given from my class which is above. Something that I didn't mention. If I just say this here, I can see all of the things that the animal has as well, in addition to what I put, which is specific for the mammal. Okay, so I can do this dot name equals name. I can do this dot age equals age, and so on. But this will be repetition of code, right? There has to be some way for me to use what I already have in the class above. Okay, so and now this is very similar. So let me just fix this now. So this way. Yeah, question.
Can you really use this dot name equals name?
Yeah, sure. This dot name. Okay, let's write it out. Okay, I have this dot age equals age.
When it's private set, it shouldn't be working for.
Okay, let's just change it then. So I will go in here, and all of these I am just gonna put as set. Yes, you were right. If I have private set, I can only access it from the class inside and not outside. I will do. We will talk about that a bit later as well. Do I have anywhere else private? No, I don't. Okay, so let's get back to the mammal, and I can do that, right? So I can say this dot weight equals weight, and so on. But this is not the idea. Then I can use the constructor and do all of that again, but instantiate my mammal the way I want. But we want to reuse the code that we've just written, right? So inside here, instead of doing this as I would with constructors from the same class, I can just say base, and then just give name, give age, give weight, and give color. Okay, and what this is gonna do, it's gonna go to the constructor, which is in the animal class. This one is gonna fill in all of the information that I want for my mammal, and then if there is anything else, and in this case there is, I have to say this dot gender equals gender, and then it's gonna go back and set everything else after that. Okay, and this is how you reuse. So let's do the same thing with an empty one. So I want to say public mammal, and I want to say base, just like that. Okay, how does that sound? Everything fine? Any questions? No, there are not. Okay, so let's go into the access modifiers that we talked about. So someone said here when I changed all of those. So right now they're by default, I think, either internal or public. I don't know, but anyway. So inside here, if I put public or just skip it, I'll be able to access it and change the name everywhere. If I put private as it was and as it should be right now, let me just put those back. I will be able to get the weight from anywhere else, any other class, whether it's derived or not, but I wouldn't be able to set it outside of this class with the word private. Okay, but let's take name. Okay, how about if I want to be able to change the value not only in this class, but I want to change it within the solution as well, within the whole solution. What access modifier should I give? Internal. Good. Internal. And now I can not only change it here in the bunny, change it in the food as well, change it in the mammal, but I will also, yeah, there. I mean, everywhere that we have, in the enumerations and so on. Will I be able to change it from here? Internal. Same project. Let's create an, actually we already have the animal. Let's try. So test animal dot name equals Goshen. Okay, and inside here it says the property or indexer cannot be used in this context because the set accessor is inaccessible. Okay, so internal meant only for the project. Okay, which meant only this thing here. Okay, now this is a separate project, and I'm not able to, you know, set the name there. Is that clear? Okay, this is internal, so I can really just access it and change it anywhere here. Let's go back to the animal and put it as protected. Okay, so now if I am in the bunny, will I be able to change the name? Yes, because it's derived class from animal, right? So we have animal, then we have a mammal, which is a derived class from animal, and then we have the bunny, which is a derived class from the animal. So with the word protected, I can access and change the property in every single class as long as it's derived, you know, from the base class. Can I change it in the food? No, because it's not derived from animal. But if I do this, which doesn't make any sense, I will be able to, right? Because food. That was a horrible joke. So the guy said, "Well, it kind of is, but yeah, bad. Okay, this lecture could be deleted from PETA or some other organization." All right. So okay, what else do I want to say? All right, let's go to the bunny. Right, let's do this. Control dot, enter, and let's put this is here. So this dot. Let's add everything else. So we have what was it? String name, int age, int weight, and color, string color, comma, and I have gender. Yes, I do have gender. So gender, which we had for the mammal. Okay, put this inside as well. Okay, and now what do I have to do? So I have to call base. But which base is it gonna call? Well, we already have the answer. It's not gonna call the animal base because it's, you know, 2 levels above in abstraction. It's gonna call the one which is directly above, and this way I can reuse code more easily. There is no way that I know of, or there shouldn't be any way to access the class which is a couple of steps above, just the one that it's immediately above, or the class that the bunny derives from straight away. So we say base, and we would like to say name, age, weight, color, gender, and that was all, right? Yeah. Okay, and now you see how, you know, easy that was. You know, just to make a bunny, we have to do just these simple lines of code, and we reuse a lot of it, and we already have a bunny, right? Yes, question.
You have to write it 2 times. I mean, string name, then base name. Can't you just make write base string name, int age, int weight?
Okay, so can I put all of this in here? I don't think so. Let's try. So let me remove that. String name, int age, int weight. Well, no, but I wonder what. Okay, invalid expression, because you're not creating a constructor. So if I put it here, int ear length, I am creating a constructor. Here, the only thing that I'm doing is calling the one that is above. It's like saying new mammal of these values. Okay, it's not like creating one. So let me remove that. I think that's it. So color, and then we have gender. Okay, and it's gonna do all of the job for us. So all of the complicated logic that we had in the animal here, which is, you know, we have this method, we have this method, we have in the one of the constructors, we have this dot alive is true. We're not worried about any of that, and we are not doing any of that because it's already done in one of the steps above. Okay, so let me change this to private. Again, I don't want to be able to change the bunny of the animal from the class bunny, and so on. All right, so let's make more. Let's make more because you know a pet shop with only bunnies is not going to be fun. All right, so let's make a new question. If the customer wants to change the name of the bunny, let's think about that later. I think. Yeah, we can do that as well. It's fine. We can change the name after he buys it. We can add the price. Okay, I have a thing for that, but it comes a little bit later. Okay, so class, and what do we want to do? So we have mammals. We have say birds, or what do you want? Fish. Fish. Okay, you want fish, of course. Right. So fish is gonna be public. Class fish. Let's delete all of that. It's gonna inherit from animal. Okay, and what does the fish what do is fish singular or plural? What does the fish have? Fish. Okay, anyways. Right, so what is specific for the fish? Scales? Fish scales. Are they called scales? I didn't know that. I want to check. In Worotafork, there are fish scales. Okay. Fish scales. Okay. Right. So, what do you want? Fish scales count or color or what? Okay. So prop G, string, fish scales color. I was thinking of something which is slightly shorter and it's shininess. Okay. No, I was thinking about public and fin length. Okay. Get private set. Question. Shouldn't fish be an interface? We don't know what an interface is, and right now it cannot be one the way I want it, the way I want to implement it. So hold your horses, and we'll talk about interfaces a bit later. Yes, thanks. This is very good of a. Okay, we can. Sorry, the fish can swim, so we can't swim, or we can. Some of us can. Public string swim. Swimming song. Near far. No, let's just put it swimming. All right. Swimming through the sea. Okay, let's not come up with songs. All right, so control dot and enter and okay, so here I have to do the usual things. So this is the one part that you have to repeat, but it's kind of hard to mess that up. So I hope that it's fine. So string name, int age, int weight, and string color. Okay, so put this here, everywhere, this dot. Okay, now we have, so let's make a specific fish. Let's make a Nemo now, so. Oh yeah, I didn't call the base. So base, and I want to call it with name, age, weight, and color. And nothing else. All right, so let's make a Nemo now. So Nemo is gonna be a class, Nemo fish, or it was clownfish, right? So clownfish, and we are gonna put the name to be Nemo because all clownfish's names should be Nemo. So public class. Then we have what does the clownfish have? Stripes? Sorry? Yes. Okay. So public. Let me put prop G, and I didn't press tab, please. So int number of stripes. That's too much. All right, and here I'll do actually something a bit different with the constructor. So I am gonna say, oh, a little bit, not much. Here I wanna say int age, int weight. We have also string color, and we have number of stripes. Did I put everything else in the fish as well? Here, scales, color, fin length. Yeah, it's fine. Let me go back here. Number of stripes, that was int. And okay, so here, base, we are gonna call with base. I am gonna call with Nemo, and it's gonna be age, weight, color, and that's it. Okay, so I can set it here straight away. I wanna call this.
Should it inheritance fish?
Yes, I should. So fish. Yeah, and now it should work.
Here the things for the fish.
We have the things for the fish, so I am calling the. Yeah, I have the things for the fish. So what was that? You know, so many properties, I just get confused. So let's go to the fish. I have scales, color, and fin length. So string, scales, color, and fin length. Int fin length. Sorry? Comma. Yeah, I heard color. Right, so instead of doing that, let's just say here, color. Let's remove that. Right, because we are gonna assume that the color of the fish is gonna be the color of the scales as well. And after that, I wanna say fin length and number of stripes. But the point was that I wanna call it Nemo. And did I do something wrong? Sorry, number of stripes for the clownfish. All right, so I don't have this here. So this dot number of stripes equals number of stripes. Must be before. It doesn't matter right now specifically, and everywhere else I did it, I think, this way. So we have the basic name, age, weight, color, gender, and after that we had the ones for the bunny. So yeah, in the fish we had name, age, weight, color, scales, color, fin length. Yeah, is it fine now? Okay. Right, so yeah, this was this is everything that I can think of about inheritance. So this is how you inherit. This is how we get the functionality from the class above. And yeah, I'm sure that I've missed something, but it will come up during the presentation. So let's have a look at what we have here. All right, so inheritance allows child or derived classes to inherit the characteristics. So we were talking about methods, we were talking about properties, and so on. That so the only thing that it's not inherited, as we saw, is the constructor, but you can still reuse it with the keyword base. Okay, so inherit the characteristics of an existing parent class, attributes and operations. Derived classes can extend. So what we did was we had the most basic functionality in the animal, and after that everything which was specific for the mammal, for the bunny, and so on, we extended from the animal. So we took the animal, everything that it had, and we extended upon it. Okay, so we added some new fields, new methods, we redefined. So we haven't done that yet. defining, but we'll do that a bit later. Okay, so use inheritance for building is a relationship. Okay, so this means that if I have something like I don't know, so the clownfish is a, and I can just add, you know, type of fish. Okay, this means that right now I have to use inheritance. If there is a has a, so something like I don't know, bunny has a heart, for example, that means that this is not so the heart does not have to be a derived class, but it has to be more like a property of my bunny. Okay, so you know, sometimes it may be a bit hard to understand which has to be derived, which has to be a property, and this is the is a test and has a test, and sometimes it can be a bit confusing. So yeah, okay. What else do we have? Use a property implementation when building has a relationship is what I wanted to say. All right. Inheritance benefits. So we have extensibility, so we can extend our more abstract classes, and we can extend them into, you know, something which has more functions, different functions, and so on, which is really good. As we saw, we reuse code quite a lot, so we reuse all of the properties that we create in the more abstract classes. Also constructors and methods and so on, everything is reused when you do inheritance this way. And the good thing is that if I want to change the method move, I only have to change it in the very basic class. Okay, otherwise, you know, it's not gonna otherwise I have to change it in like 10, 20, 100 places depending on your architecture, and you know, you may miss some place and so on. It's not gonna be good. Okay, provides abstraction. So this is the thing that I've just mentioned. So once I've abstracted it enough, it will be a lot more easier to maintain, to make changes, and so on. Okay, eliminates redundant code. So that thing that I showed you with the constructor, where I can still do this dot name equals name and so on, I can just reuse the constructor from above and don't repeat myself when I write code. Okay, important aspect. So structures cannot be inherited. Okay, a structure is only to hold your values like data types, something like position, coordinates, vectors in math. So something that has just a bunch of fields or a bunch of properties. Structures cannot be used for inheritance. Okay, in C# there is no multiple inheritance. And this is really important to know, and it's actually really good that there isn't, because say that I was allowed to do that, and I had a bunny, and I said, well, the bunny inherits from the mammal and inherits from the fish for some reason, right? It doesn't really make sense purely logically, right, to inherit from more than one parent class. Okay. And this really is very good for beginner developers, because you cannot do it wrong, right? You can only inherit from a single class, which you know what it has to be, and you just do that. If you're allowed to inherit from multiple classes, and this was the only way to do it, you could get confused very easily. So this is a good thing. But you know, this would be kind of not so cool. So there is kind of a way around it, and this is to implement different interfaces, and we will talk about interfaces in a bit after right after this slide. Okay, so an interface is not a class. It's something that just gives you the structure of your class, or you know, some specific method, some specific properties, some functionality which is you know, specific for this interface. And interfaces, I can implement multiple of them. I can implement a lot of them, as many as I want. So let's say that I have an interface which is iMove. I would be able to inherit that one. I can inherit iJump, iFly. I can inherit iPet interface, which we are going to do in a second, but I can do all of them. So only one class, but multiple interfaces if I want to add, additional functionality. Constructors are not inherited, but they can be reused. So this is good. Inheritance is a transitive relation. So what I talked about. So we had an animal, we had a mammal. So let me just change the color because this is not very nice. So we had an animal, we had a mammal, and we had a bunny. Okay, and we said the mammal is an animal, the bunny is a mammal, and so the bunny is an animal. And this is what we mean by transitive relation. It's something like in maths when I say A equals B and B equals C also, or therefore A equals C. So this is the same thing. Did I do a mistake? No, it's fine. So this is the same thing. So the mammal is an animal, the bunny is a mammal, so the bunny is an animal as well. You all got that? It's pretty logical. And this is another reason why you don't need multiple inheritance, because with the bunny you can think of that I've inherited both from the mammal and from the animal, but in fact I only did inherit the functionality from the mammal, and it already had all of the information that I needed from the animal. Okay, you cannot remove inherited features. So let's say that I want to have a bunny which doesn't have a name in my specific example. You cannot do this. Okay, you can set it as an empty name or something like that, but in general, whatever you have in your base class or in your parent class, you have the same thing in your child class, and you cannot change that. You cannot choose the methods that you want to use and the ones that you are not gonna use. If you have problems with it, then you have to rethink your architecture. Maybe split one of the more abstract classes into two, or split them into interfaces if you want to, and so on. So there are ways around it, but if you have this problem, that means that you have to change something in your architecture. Okay, a class can declare virtual methods and properties, and this is something that we will do probably after the break. I don't know how long have I been talking for. Okay, an hour, so yeah, let's have a break. Okay, let's get back to the lecture, and right, so we'll be doing, this thing, virtual methods. Virtual properties you really are probably not gonna meet ever in your life if you're doing games, but they can be useful maybe if you want to change the validation of a property or something like that, but we are not gonna do that now. But virtual methods are really good. And you've already used virtual methods and overriding them without probably knowing. And this is the toString method. So if I now go into object, so let me just press here, object, and press F12. And here we see that toString method is virtual, which means that it can be overridden, or you can change the functionality of it or to extend it however you want by declaring this word virtual. And this is what we'll be doing now, and it's not that complicated. So let me just go into my animal, and right, so I want to say move or eat. What do you want? I'm an animal, right? Move is in mammal. Okay, yes, okay, so I have a better idea. Okay, so this, it says I like to move it, okay, good, but I want to change that, so I want to say here virtual. And let's go to the bunny, which can move. I haven't said it here explicitly, but if I now go and test get a bunny, so let's make a bunny. Bunny, my bunny equals new bunny, and here I have to put a lot of boring things, don't I? So let me just go in here and make this hack. Oops. And I'll go back here. Now I'm fine, and I can say my bunny, or console write line my bunny dot what was it, move. Okay, I have it, I can use it. I cannot see it anywhere in the bunny, but it's derived from the more abstract class, which is mammal. All right, and here, so move, and that's gonna work. I hope. Can you imagine? I have, yeah, I didn't remove this now. Okay, this is what we have. Okay, it's derived from the mammal class, but what happens if I want to change the functionality there? Okay, so let's go to the bunny and say public override, and if I press tab, it should give me the methods that I can override. So it's these three, but if you can see here, I also have the move method, which I see here only because I marked it as virtual. So I can say move here. Okay, and you see straight away the autocomplete calls the base dot move. So right now I'm not doing anything special. If I run it again, I am gonna have the same thing. Okay, if I delete it, so go into the bunny. If I delete this and just say return empty string, now I don't have anything here. Or let's just put some a here. Okay, a, which is now different. Let's say that I want to extend the functionality, and I am gonna say return base dot move, and I can say plus I am a bunny. Don't eat me, as some people in the audience wanted to do a couple of lectures ago. So yeah, don't eat me, and I'm gonna be polite and say please. Okay, and now I like to move it, and then I am bunny, don't eat me please, which is exactly what we wanted. So say that you have some really complicated long method that you wanna instead of rewriting it, I can make it virtual, call the base method, and then extend a little bit of it. Let's say some complicated algorithm for generic list that I've made. If I make some more specific list under it, where I only have to change one or two lines, or just add one or two lines in the end of the method, I can just reuse the method from the base class. So as soon as I call base, by the way, it's not only for the constructors. I can call base and use a lot of things of it. So I can use the name, I can use is alive, and so on. Weight, age, color, everything that you have which is on top. So it's not only used here. It's like this keyword. So here I can say this dot ear length, this dot fur density. Inside here I can say this dot move. I can say anything that is specific to the instance of my object, of my class. Sorry, and it's the same with base. So base, but it just calls the all of the functionality from the class which is above in the hierarchy. So like the parent class. Okay, is it clear? So now if I say move, this is fine. I'm adding a bit more, and I'm just changing the method. I can change it completely as well, just delete all of that and do a different logic there. Anything that you want to do, as long as it's virtual here. So if I delete this and I say where is my bunny? Okay, so now let me remove that as well, and this as well, and this as well. Okay, so now it's a bit ambiguous. What am I trying to do, right? Am I trying to make a new method move, or am I trying to completely hide the one that comes from the base class? So here, instead of error, because this is allowed, I get a warning, which I don't know if I'll be able to see here. Warnings, and it says bunny.move hides inherited member memo.move. So I already have this method move, and I'm completely ignoring it in always possible. So I'm hiding it from everyone else. Where in fact I may want to use the base one for some reason. So the correct way to do this, if you want to change something, is to put override here, and to make this memo public string, make it virtual. Is that sort of clear? Okay, if you ever forget this, just remember what I did. So I said object F12, and inside here you will always remember the toString method, which you've overridden quite a few times now, and you will see that it's just virtual. And there are others here, so I can do equals, we just compares objects. I can do yeah, and I can do get hash code, which I haven't had the pleasure of using. Okay, so right, where were we? Let's get back to the presentation. Okay, any questions about the inheritance? So we made some parent classes, we made some derived classes, we reused constructors, properties, and so on. Do you have any questions on inheritance? No, everything is fine and clear. Okay, abstraction, and before going into the demo, I would like to go through the slides just to see what that is and what we achieve with it. So abstraction means ignoring irrelevant features, properties, or functions, and emphasize on the ones relevant to the specific project. Okay, so right now I don't have a specific project, right? I'm just testing stuff, so there is no good way to explain this with the current project. But if your game has bunnies, you wouldn't care about the fur length or color of eyes or breed and so on. Just focus on what you want to use and what is actually relevant to your game. Okay, so if I'm making something like a student system for the academy, I'll have probably name, ID, marks, and something like that, but I won't have a field or a property which is color of eyes, because I don't care about that, right? It's specific to my application, what you have to include. Okay, abstraction helps managing complexity. Okay, so if you saw now, if I actually try to make a new bunny, let's say a new type of bunny, it will be easy enough just to inherit the bunny class, and everything will be there. I'll have the name, the age, the fur length, or weight, is alive, and all of the methods above, and so on. And this will happen with just a few lines of code. So this is one thing. So if you're like a team lead or a senior developer in a company, you would have to worry about the more abstract structure and architecture of your application or a game. And if you're junior and just starting, you may enter a very big project where they just say, well, look at the code and just implement a new type of bunny, and it'll be very, very easy, because there are 10 other types of bunnies, and you can just see how are they doing it and do the same thing with only a couple of changes where they are needed. Okay, so it really is a lot better with abstraction. Okay, abstraction in .NET can be done with the use of abstract classes or interfaces, or both, and we'll see which one is what, and what's the difference, and so on. Okay, so first up, interfaces. Interfaces define a set of operations and attributes. Okay, they do not provide any implementation. Okay, this is very, very important. So I only list a couple of methods, I only list a couple of properties that I want to have, and I don't deal with implementation. So whoever implements this interface, they have to worry about how to implement these specific properties and methods, but it's not the job of the interface. So the interface only provides a contract for implementing the defined features. So let's say that I don't know, I want to have interface which is I jumpable. Okay, it will have a single method in it which is going to be called jump, but I never say how my bunny or how my animal is going to jump, right? I just say, well, if you want to implement this in the interface, you just have to you just have to implement the method jump. Okay, there is hierarchy or inheritance in interfaces. So I can have a more base interface. I can have a one that is derived from it, which is a bit richer in terms of functionality and so on. Cannot be instantiated. Well, there would be nothing to instantiate, right? You don't have, specific properties. You don't have specific methods. It's just a contract. It's just a skeleton for your classes to follow. Okay, we are not there yet, so let me go back. So let's have a look at a couple of interfaces, and the easiest thing is to just say list, press F12, go to definition. We cannot go to the definition, which is a shame. All right, so here is the list. How many of you have done the homework with the list, where you have to write your own generic list? Why? Is it complicated or you're lazy? You're waiting for the end date. Good. For the demo. I already gave you a demo and I kind of wrote half the code. From the lecture, I implemented half of your homework for the list. Oh, the demo is not there. I think that I put it up. Let me just check. Let me just pause this for. Right. So let's get back to the list. So yeah, the list. Let's have a proper look. So list of T, which means that it's a generic class, and it does not have a class that inherits from, but it has a lot of interfaces. So if you see here, we have all of the interfaces that it inherits from or that it implements, but we don't have one class that it inherits from. Okay, so we have these constructors, we have the indexer, we have some properties, and then we have some methods as well. So let's have a look here. We have that list of T. It implements an interface which is iList. Let's have a look. So iList, this is an interface. It inherits from other interfaces or implements other interfaces. So the iList has an indexer, has some method which is index of, insert, remove at. All right, let's have a look at another one. Let's have a look at IEnumerable. So IEnumerable, what it does is just allows you to for each your collection or your class. So everything that it's gonna have is this method which is called get enumerator, which is just gonna allow you to for each a loop. For each a collection or a class. All right, let's get back to. I wanted to get back. Okay, to my list. Okay, here we have I collection, I read-only list, read-only collection, and so on. So, yes, there is a question.
So there is inheritance. It's not like the classes like bunny inherits mammal and mammal animal.
It's not like bunny inherits mammal, because if you see, this is actually not a stripped down version of the code. This is precisely the interface. Okay, there is nothing hidden here. It just tells you I want to have this method and I want it to return this thing.
It's written.
He's talking about transition. But
It's inherits enumerable, but you write it at the list again.
It's written on the list.
It's written in two places, but I think it's Microsoft there.
So
Read it.
what is the problem here? So I have the I enumerable here,
Yeah.
and I have it say here as well in I collection. Is that the problem?
Yeah, something like
Yes.
Okay, so this is not a problem. This is one of the things that you have to follow when you do quality code. Okay, so here it's a lot easier to see what kind of things are in my list of T when I just list them all. And there is actually a very specific order in which you should do them. So the most abstract ones are in the end. So this I enumerable just gives you for each loop. So it's the most, you can say that it's the most abstract structure in C#.NET, because you know this is just a set. Okay, it's nothing else. It's just a set. You don't have indexers. You don't have count. You have nothing. You just have a set of elements, and I can go through them one by one. This is the only thing that I have. Okay. After that, let's go to our collection. This is a bit less, right? I have the for each and so on because I inherit from I enumerable, but I also have count. I can count how many elements I have. In the other case, I couldn't. I can just for each them. Okay, we have a copy to method as well, and so on. So yeah, the point here is, and the reason why it's done this way is that I can very easily see what features I have in my class. So if I say bunny inherits from animal, and it implements I jumpable, I movable, I edible, or something. I edible was actually quite funny, but anyways. So yeah, if it implements all of these interfaces, then you can straight away see how your bunny is gonna behave, right? So this is the idea. So you have to put, normally you have to always try to abstract your logic into interfaces so that it's a lot more easy to read, as well as the list. So with the lists, since you haven't seen these collections, I guess it's a bit hard to understand, but if I do it in my project now, you'll see how useful and how good it is to have listing so many interfaces. It will be very simple to see the functionality of the bunny. All right, so let's do that. So I said that I want to add a new, I can do it from here, I think, if I put interface. Okay, but it will be the same thing if I add a new class and then just delete the class word and put interface. So it's nothing. So let's do iPet. So interfaces are normally called with an I at the front, and there we go. So interfaces, I think, should be public, because you can use them and you can inherit from them all the time. So this iPad should be in interfaces here, and I have to change this to interfaces. Okay, so what does the path have that that we are gonna need? Is that me? No, someone else. All right, so what does let me just fix this. What's your problem? Okay, I still have the object. Okay, so what does a path have that normally an animal doesn't have? Owner. So public string owner, and I can say get, I can say here private set, and so on. So the problem here is that I don't need the access modifier. So if you're declaring something in your, do I even need to have this? Get set. Right. Okay, so if I am declaring something here, and if I want to implement it in another class, it is going to be assumed to be public, right? Because why would you want to have an interface to describe a structure if no one is going to be able to see the structure? Yeah, so this is by default public, and I can use it in as soon as I want to implement it in another class. So let's say that the bunny is it's not just a mammal, it's also iPet. Okay, and now if you see here, it says that bunny does not implement the interface. So to do that, just press Control dot, implement interface, and somewhere around here where I get the owner, throw new not implemented exception. So this is what I have to do in order to finish my finish my bunny and make it an iPad. Right, so what's the point here? That everything that's in the interface I want to be able to expose to the outside world, and this is the reason why I make interfaces, so they work as a some sort of a skeleton for some functionality of my class. All right, so here just make it like a normal property, so get and private set. And please notice that in my iPad, I can have get and private set. I can just remove that, and I can let whoever implements this interface to worry about whether you want to have it, whether you want to have it private or public, and so on. So this thing only says, well, I want to have a property which is public of type string, which is called owner, and has a getter actor. This is everything that I'm saying. I'm not saying what it does, what it gives. I am just saying that I want to have this. So same thing for methods. So pets, they can I don't know, let's say void invoke happiness. Okay, and I am not saying what this thing is going to do. I am just saying I want to have this method. It's going to be void, and it's going to do something whatever you decide, but you have to have this method. So now if I go back to my bunny, I still have this error. Control dot implement interface, and there we have it. And let's say actually let's make it a string, which means that I am not following the so let me just put it here, return empty string. So as soon as I changed it here and not in the interface, this means that I have not accomplished the contract with the iPad. So if I do it again, I am gonna have a different method, which is now gonna be of type void. Okay, so I don't want to do that. The only thing that I wanted to do is just mark it as a string. So let me go back into my iPad, and let's just put this to a string. Okay, let's go to the animal. So I'm sorry, to the bunny. Where's my bunny? Okay, here invoke happiness. I don't know, how do bunnies invoke happiness? Just by existing. Okay, being cute. Being cute. Okay, if it was like a dog. Okay, so let's do another one. Let's do a dog. So add new class, and I'm gonna say dog, and so the dog is an animal or a mammal, and is also iPet. Remove all of that, put this inside the namespace here. Pet shop model. Insert. I don't know what's happening. I'm used to another keyboard. So model. Okay, and now let's implement this. Okay, and here I can do something else, right? I can just say return wave. Sorry, how's tail? Wave tail. Or jump on owner, lick owner, and so on. I can even say here once I have this owner property, which I'm just gonna, let's just put it here, return. Actually no, I want to make it automatic, so get private set lick, and then okay, I want to do something else. So string.format lick, and I have to say here this dot owner to string. No, it's already a string, so it's fine. Yeah. And now I already have a dog, right? So I don't have to do anything special here. So if I want to just make a dog shadow, I'm gonna call it a new dog. I would like to not use your suggestion and add it to my right. There is some problem here, so this has to be public, of course, otherwise, you know, I'm not going to be able to instantiate it. Okay, so now we have the dog. Why are you not in blue? Okay, you are in blue now. And I can say console right line shadow dot invoke happiness. And voila. Okay, if I gave the owner a name, then here in the lick it will be fine. Actually, can I do that? Can I just go to my dog and say set here, and I am gonna say shadow dot owner equals Joro, and there we go. We have it already. Yes, question.
When we make the methods in the interfaces,
Yes.
we make them to return objects so we can change it when we implement it.
You cannot change it. So okay, so I see what you're saying. So I think your question is, if I put object here, can I change it down the line and say, so if I say object here, can I say in the dog, can I say here this to be string as it is? No, because it has to be an object. And here, if you see, I still don't implement the interface this way. You cannot make it var, because var guesses what your type is. If it has nothing to guess from, it's not gonna do that. Dynamic. Okay, let's do that. I've never tried that. So let's have a look. So I would assume that it's gonna be the same as object, but you never know with this type. So I don't know. So bunny. No, it was dog. And yeah, I still don't have it. So yeah, this thing has to be a string. All right, what other interfaces can we make to make this better? Okay, when I say you normally have to have interfaces for everything, I'm really not joking. So if I say list, nope, I didn't want to do that. I wanted to press F12, but you know. Okay, so here I have, you know, the class which is called list. Okay, it does iList, iCollection, iList again. So this is the generic iList. This is the non-generic one, and so on. So you can think of, you know, you can abstract anything that you want. Okay, say for the animal, I can add an interface. Let's do it the other way now. So I'll just put a class which is going to be iAnimal, and I am going to have all of the things. So public interface iAnimal, and inside here I am going to have all things. So property, what was it now? String name. What? Oh yeah, I don't even have to write this. So yeah, just string name. I want to have, what did we have? Int age, please. I want to have get, help me, int weight. Wait. I want to have a get here. What else do I have? Color, so string, color, get. What else did we have for the animal? Gender was for the mammal. So yeah, if you, I was just wondering if you remember. So I have is alive, so bull is alive. Then I have eat, reproduce, and die. So what was that? Bull is alive. Get. I had now the methods which were void. No, it wasn't void, or it was, yeah, void die. What else did I have? Eat. So void reproduce, and I had void eat, and I'm not sure if those were void. Let's have a look. So string eat food, and then the other were void. Oops. So this was string. Alright, and now if for some reason I want to make a different type of animal, say like from another planet, but I want him to keep these and just add more, or I can just say an animal doesn't have a base class, but it implements the interface, which is iAnimal. Okay, and I have to add the interfaces here, please. Thank you. Using pet shop interface preview code, yes, apply. Okay, and I have to put this inside and so on. For some reason I get an error. String name. Do I not have a name here? I have a private set, but it doesn't matter. That's what I'm saying. Oh yeah, I have a set here, so I should remove that. And now, everything should be fine. Everything should be fine, I said. Does not implement in the interface member eat. Public string eat food. Oh yes, so I have to do this signature as well. So inside here, not only like the name of the function, but the full signature. So here I have to say food, and I don't have the using for this. Oops. And now it should be fine. Okay, so where were we? We were in the animal. Okay, now I have it, everything is fine. The thing is that now I have to add this in the interface to every single other class that I have, right? So the bunny is mammal, implements iPad, also implements iAnimal as well, right? And so on. I have to add it everywhere down the chain, and again, the most abstract ones should be furthest to the right. And now, if you can see, to answer your question from a little from a while ago, so this is now very, very easy to see and easy to know what your bunny is. So I have bunny, which is a mammal, implements iPet, so it has some pet features, and it also implements the iAnimal, which I could have kind of guessed because it has mammal as well. So normally what you have to do is, if you have mammal here, you should make an interface for a mammal as well, if you need it. And normally this is actually how you start. So we did it kind of in reverse, where I first implemented a couple of things, and after that added the interface. Normally you just start with an interface, right? You only have to think about what properties do I have, what methods should I have, and after that, when the time comes, when you have your full structure, which is just filled with interfaces, after that you can just make a class, say, well, I implement iAnimal, iPad, iMammal, and so on, and it's going to generate all of the methods that you have to use, and you just have to fill in the gaps, which is a lot more a lot easier to do. So this is the point here. If I have all of them, then just pressing control dot. It's just gonna generate all of the methods and properties that I want to have, and it's gonna be a lot easier for me to implement after that, just filling in the gaps. Any questions here on interfaces?
So if I have an interface I memo,
Yes.
I memo inherits I animal.
Yeah, I have to put them both.
Just for C.
It is okay. So the the question is, if I have iMammal interface, which inherits from iAnimal, right? Which implements iAnimal. Do I have to include them both? Well, the answer is no. It's gonna work without you listing them all. So inside here, if I just say iMammal and delete iAnimal, it's gonna work as well. Let's just assume that I have it. It's still gonna work, right? Because you have all of the features, they're inherited from the iAnimal and so on. But the point is that you have to list them all, because this gives you a very specific structure of your bunny. It's a lot more easy to read. So let's get back to the list here. F12. Right, so inside here, if I only put this iList inside, it's gonna generate all of these methods inside. All of these, they are stored. So here in the iList of t, we have these three. Okay, in the I collection we have more, in the I enumerable we have more, and so on, right? So I don't have to, technically I don't have to write all of them. I can just go on with iList, which is fine. But the point is that this way it's a lot easier to read. What do we have? So the list is an iList, it's an I collection, it's a read only, and I can for each it. If I can read all of that, then it gives you a pretty good idea. And the thing is that if I have, let's go back to the bunny and change that. I don't have iAnimal here. So yeah, this is just the only one class that I can inherit from. If I try to inherit from animal as well, I will get an error. I cannot do that for more than one class, but I can implement multiple interfaces, which is cool. Any other questions? Nope, everything is fine. Let's fix the error here again. Okay, let's get back to the presentation. So yeah, I cannot make an instance of an interface clearly again. Interface. Maybe I did that in a couple of other places. Interfaces. Thanks. Right. Okay. Abstract classes. So an abstract class is something in between an interface and a normal class. So an abstract class partially or fully provides implementation. Okay. So I can skip it the same way that I did with the interface. I just describe the method, but I didn't give any implementation of it, so I can just skip it, or I can implement it in full. Okay, and right, so not implemented methods are declared as abstract and are left empty, same as the interfaces. Abstract classes cannot be instantiated, and this is kind of the point, right? If I have an abstract animal, right? If I tell you, if I go into the pet shop and I say give me an animal, they can give me whatever they think it's fine, but I can think of something else, right? So this is very non-descriptive, is very abstract, and there is no need for me to instantiate it. Okay. Child classes which are not abstract should implement all abstract methods. Okay, so again, I can have a structure, or I can have a hierarchy where I have an abstract method as a parent. I can have a derived class which is also abstract, and I can just skip implementing some methods until I get to a regular class which is not abstract. But we'll see that in a second. So is there any more information? No. Okay. So of these specific classes, which do you think should be abstract? Animal and mammal and fish. Okay, so let's make this one public abstract class. Let's make the mammal public abstract class, and let's make the fish. Alright, but here we didn't change much with the code, right? So I can still, the only problem that I have here is that I cannot say animal new animal equals new animal. Okay, so this is going to be the problem, and you should be able to see why. Cannot create an instance of the abstract class or the interface animal. So it's the same as an interface, but in this case I only changed this not being able to instantiate it just by saying that it's an abstract class. Okay, but what does this give us? So let's go into the animal, and let's say that this method, which method? Let's actually put the move inside here. Void move. And I'm gonna go into the animal. I'm gonna implement it, and let's see, where do we have it? Here, public void move. Okay, so if I don't wanna implement it here, if I wanna say, well, move is too generic and I wanna be able, to differentiate between the bunny moving and the fish and so on, I can just say abstract here, abstract. And I can just not do any implementation, the same way as with the interface. So here, this is the only thing that I am doing. I am just saying, well, I don't wanna right now. I don't wanna implement this method. I'll just leave it for my derived classes. So I have to do the same thing for clearly for the fish. Let's just remove this as move. Okay, and the fish is gonna say that it's is it void? And I wanna say console right line swimming. Override. So once you have an abstract one, you have to override it as well. So fish, and then I have the mammal, which also has move, and let's change this now. Let's make this abstract, or no, let's just leave it as it is. So override, and I want to say void. Alright, where else do I have it? I have it in the bunny, probably, move. Okay, and here, I can just leave it as is. I can just say, return base. So override void move. I can just say base dot move, and I'll just call the one from the base, and it's gonna be fine. Actually, I cannot build this one. Okay, I can. So let's make the bunny. Let's make an animal. Actually, I don't have a specific type of fish, right? So yeah, I want to do something else then. So base dot move. Oh yeah, I have it. Yeah, I have it. Console right line. I want to say here, I'm a bunny. And let's go to the clownfish as well, and here I want to also do the move method. So public void override, public override void move. I wanna call the base move, and I wanna also say I'm a fish. All right, and now let's create a. Shouldn't we do that in the fish class? Well, in the fish class, okay, I'm a clownfish. I wanted to do. I'm a clownfish. Just so that you see that once we call the same method, it's gonna be seen. So let's create. I cannot create an animal. I cannot create a mammal, but I can create. But I can create a clownfish. So clownfish, Nemo. And again I have to create an empty constructor here not to get this error. And okay, and then we have a bunny and I want to call my bunny dot move and I want to create Nemo dot move. I want to call. What?
The name
Oh yes, the name Nemo. So this dot name equals Nemo. No. Why are you not working? That corresponds to the required parameter name of fish. The constructor of fish, yes. And now you should be fine. And now I should be able to do that. Okay, I'm a bunny, and then swimming, I'm a clownfish. And that is fine. Okay, right. Question, yeah. The difference between a virtual and an abstract method. So a virtual method is implemented. Okay, you cannot leave it as I did with the animal. This is the one thing, and the other thing that if you want to have a method is abstract, your class should be abstract as well. Okay, which means that I cannot instantiate it. So I can have a virtual method inside a normal class which I can instantiate. But if I want to have an abstract method to leave for implementation for the derived classes, then I have to call this class abstract as well. Yeah. Any other questions? So what's the point of abstraction? Can anyone guess? What's the point? So why do I create these interfaces? Why do I create all of these nonsense abstract classes and so on? Yes, sorry? Easier to read, okay, but what kind of functionality do I gain from using more abstract structures? And I'll start typing some code here, which is going to be unrelated to my pet shop, and I guess that you will be able to kind of guess what's going to happen. Okay, so let's have a list of integers. And this is going to be called a list int. Let's just give some values. Okay, and I want to make a method. So this method is going to be public static void print list. And inside here I would like to call list of int and list int. Sorry, just some list. And inside here, what I want to do, the only thing that I want to do is your hint, is I want to for each, and I want to say var item in list, and I want to say console write line item. Okay, it's very clear what this is going to do, right? I'm just going to print every single number. Why are you not working? So new list of int. And you're working now. Okay. No one knows? Still? The only thing that I'm using in this method is for each. Right? Now, what's going to happen if I actually create list of string? List string equals new list string, and this is gonna be A, B. What happens if I actually want to make an array? I want to make how did you declare array? So let's do double array equals new double of, can I now just do this? 5.5 3.3. Let's do that. Okay, so now let's say that I want to do the same method. I want to execute on all of these, right, and much more if I needed to. I would have to write public static void print list for list of string, then for an array of doubles and so on. But the only thing that I'm using here is the for each. So instead of doing that, inside here I can change this to IEnumerable. Okay, and of course I have to say T here and T here, because this is the example that I gave with the list of int and list of string. And now I can call this method on all of these, and it is gonna work. So this is what abstraction helps me with. I only use, so in this method I only use the for each, right? So what is the thing that I need to for each? If I'm not gonna use anything else, I can just do the enumerable of T. So now this is not gonna work because it's an array, but I can easily create list of animals, or IAnimal, which is more abstract, and I'm not allowed to access it. Why is that? Because I don't have it here. So let me do that. So now, if I wanted to create, a list of all the animals in the shop, instead of doing a list for the bunny, instead of doing, a list for the clownfish, for the dogs, and so on, I can create a single list, which is going to be list of IAnimal, and I can say list, or, animals in the shop, and that equals new list IAnimal. And inside here, I can just add any of the animals that I have. I can say animals in the shop dot add, and I can add here a new bunny, a new dog, a new clownfish, whatever I want. I can add here, just because I operate on a more abstract level, right? Instead of doing a list of bunnies, I made it a list of an interface, depending on what you want to use, right? It really depends. Yeah, question. No. So here I have a list of IAnimal, right? And my method works for IEnumerable of T, where T is, any type. In this case, I have a list of IAnimal, which is my type T, right? So I don't need to implement anything because my list already implements IEnumerable. So yeah, the list here, if I press F12, list of T implements IEnumerable of T, so I'm fine, right? Okay. Where am I? Here. Yeah, is it clear now why is it useful? If you have a good architecture, it could save you a lot of work. That's the point.
So the architect is the hardware and the better?
I wouldn't say no. I wouldn't say better. Depends on what you want to do. So the question is if you want to be the architect of an application, or the way you normally call it, senior dev. It requires a bit more knowledge, a bit more experience, and you would have to be able to look things from a more abstract perspective. So once you do the structure, you give it to others to implement because you've done most of the job. You have given all of the structures, you have given all of the methods, all of the interfaces, classes, and abstract classes, and so on. What is left is just to tell the other developers, so I want to have a bunny. It has to implement iPad, iAnimo, iMamo, and so on, and then they just do that. But for him to create this structure, to come up with it, is a bit more complicated and requires a bit more work. I wouldn't say that much of an imagination. I would say, because imagination, if you were given a project from outside, if it's not your own, then you have to go into some ideas which are not yours. Okay, and so then it's not about imagination. It's more about just experience. Okay, so I have this. Okay, so our client wants this. This is how we're gonna do it, because I have the experience. I have seen similar structures and so on. Yeah, I would say that both are interesting. I enjoy both things. I enjoy making the architecture, and when I have to write some algorithms and stuff like that. So both are interesting in their own ways. Okay, any other questions? Nope. Encapsulation. So fields are always declared private. Okay, so a field is something internal, something that no one from the outside world should see. Constructors are almost always public. Very rarely would you see a constructor which is private, although you can make one. So a private constructor means one that you can use only within your class, which is kind of hard to think when it's gonna come in handy. But sorry, singleton classes. Yeah, we're not with design patterns yet, but you can, but it's rare. Interface methods are always public, because they define the skeleton, and the skeleton is what the outside world should be able to see and use. Non-interface methods are declared private or protected. Okay, and hides implementation detail and reduces complexity. So I think I've mentioned this. Imagine one of either lists or collections or sorted hash tables and so on. All of them could be very, very complicated, but they are presented to you in a way so that you can easily use them. So just adding a single element to one of these more complicated structures could require hundreds of lines of code and complicated structures like graphs and trees and so on. But all of this is hidden from you, and in reality, you don't need to know about it. You just need to be able to use it, right? So yeah. Okay, so here is the homework. You have to implement a school with some, classes and teachers and so on. And then another one, you have a human. From the human, you have a new class which is student. We have a worker, I think. Define a class worker. There it is, and so on. So it's a bit easy. It's more text, and but I assume that you should be able to do this relatively quickly, because you saw that it's fairly simple to just inherit something. Okay, so references and questions. Do you have any questions? Nope. I guess that's it.